All right, here we go. This is Math 2. This is Unit 1, Worksheet 4. This is Mr. Trutna. And what we're going to be doing in this assignment is that we're going to be simplifying to the simplest radical form, and then we're going to show all valid and appropriate work. So we're going to start with number 2. And what we're going to do is, so remember to simplify. The first thing that we do is we look at the radicand, which is the number that's inside the radical symbol, and if it's not a perfect square number, then we have to make a factor tree of it. Okay, so 24, I'm going to go with 6 times 4, because 6 times 4 is 24. Now remember, if you go with 8 times 3, or if you go with 12 times 2, it's not going to matter, because when you're done factoring, you should end up with the same amount. Okay, so I'm going to keep factoring until I end up with non-factorable prime numbers. So 6 can be factored into 3 times 2. 3 cannot be factored, so I'm going to circle it because that tells me to stop. That is a prime number. 2 cannot be factored, so I'm going to circle it because that tells me to stop, because that's a prime number. And then 4 can be factored into 2 times 2. So I'm going to stop at those 2's as well. So the first step that we always do is that we factor using a factor tree, and we end up with nothing but prime numbers. Then the next thing that we do after we factor, then we're going to rewrite 24 as the product of all of these factorable prime numbers, which are 3 times 2 times 2 times 2. Okay? And then the next thing that we do after we write out all the prime numbers, multiply them back out. These numbers had better multiply to make 24, and 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So I know that these numbers give me a result of 24. Now what I'm going to do is I'm going to circle all the twins or all the identical pairs of numbers that I have. So you can see I have an identical pair of 2's. Okay, I'm going to circle those. And what happens is that these 2's, what they're going to do is they're going to get eliminated from the inside of the radical symbol, from the radicand, and they're going to go outside, and they're going to end up in front of the radical. So I'm going to end up with the 2 outside. Now why is that? Well, 2 times 2 is 4. The square root of 4 becomes 2. So now I'm ready to write my solution, because there are no other twins or identical numbers that I could write. Okay, so I have a 2. I have the radical symbol, or the square root symbol in this case, and then left over on the inside, I multiply it out. 3 times 2 is 6. So there's my answer to number 2. Moving on to number 3, I have the square root of 60, or the radical 60. So 60 is not a perfect square number. Like for instance, if we did number 1 and you didn't have to do this, number 1, 36 is a perfect square number, so you don't have to do any work. And if I did assign you number 1, well, you would have just said that is 6. So 60 is not a perfect square number. So I have to make a factor tree out of 60. So what I'm going to do when I make my factor tree, I'm going to choose 6 times 10. Remember, there's more than one option. And I'm going to keep factoring until I can't factor anymore. 6 factors down into 3 times 2. I can't factor 3 anymore, so I'm going to circle it. That means it's prime. I can't factor 2 anymore, so I'm going to circle it. That tells me to stop. It's prime. I move up here to 10. I can factor 10 into 5 times 2. And I can't factor 5 anymore, so it's prime. I'm going to circle it, and I can't factor 2 anymore. Okay, so then once I do that, then I'm going to rewrite my 60. And I'm going to rewrite my 60 as a product of all of my prime factors. And I'm going to write them in order from small to big. So I have a 5 times a 3 times a 2 and times a 2. Okay? So after we rewrite all of our factors, multiply them out, make sure they equal the radicand that you started with, which is 60. 5 times 3 is 15. 15 times 2 is 30. 30 times 2 is 60. Then I'm looking for identical pairs of numbers. So here again, I have an identical pair of 2's. So I am going to eliminate them from the inside, from the radicand, and I'm going to move it to the outside. But when I move to the outside, they just become the number that they are. So that means I'm ready to write my simplified form. So my simplified form is going to have a 2 on the outside I'm going to have the square root symbol, and left over is 5 times 3, so I have 15. So number 3 would simplify to 2 square root 15, or we could say this as 2 times the square root of 15. Number 4. Now we have a negative symbol here, and we have the square root of 126. So I'm going to start by making a factor tree of 126. So what could 126 be? Well, I could go 6 and 21. Okay, I could have went 2 and 63. Either way, it doesn't matter. But I'm going to keep factoring. 6 can be factored into 3 times 2. I can't factor 3 or 2 anymore, so I'm going to circle them. That tells me that they're prime, and I stop. I move up to 21. 21 could be factored into 7 times 3. And I cannot factor 7 anymore because it's prime, and I cannot factor 3. So I now am done factoring 26. Now when I rewrite 26, I'm going to put the negative symbol. Don't forget the negative symbol. Then I'm going to put the radical symbol, or the square root symbol. And then I'm going to write my factors. And I'm going to write them from big to small. So I have a 7 times a 3 times a 3 times a 2. Multiply these back out. Make sure it equals 126, which is the radicand that I started with. Now I'm going through here and I'm looking for identical pairs or twins of numbers. So you can see I have identical 3's here. So that means that they get eliminated from the inside, the radicand, and they get moved to the outside. So that means when I write my simplified form, I have a negative 3. I already had the negative out there, and I put the 3 there, so I have a negative 3. I have the radical symbol, or the square root symbol, and left over I have a 7 times a 2, so I have 14. So number 3 simplifies to negative 3 radical, or square root of 14. Number 5, I start off with the square root of 147. Okay, so what I'm going to do is, I'm going to say, alright, is that a perfect square root number? That is not a perfect square root number. So then I have to make a factor tree of 147. So I have a possibility of, I could go 7 and 21. That is 147. Anytime a number ends in 7, you could usually go 7 times something. 7 I cannot factor anymore, that is prime. 21 I can factor, and that becomes 7 and 3. 7 is prime, so I stop, I circle it. 3 I can't factor it, so I stop and I circle it. So then when I rewrite this radical, I'm going to put the radical symbol, and then I'm going to write my product of my factors from my factor tree here. 7 times 7 times 3. Multiply those back out, it should equal the radicand that you started with. 7 times 7 is 49, 49 times 3 is 147. Now I'm looking for twins, or identical pairs of numbers. I have identical 7's. So I eliminate them from the radicand and I move it to the outside. So I'm going to have a 7 here. Now why is that? 7 times 7 is 49, and the square root of 49 is 7. And you can see I'm done. I have no more twins. So that means my simplified version is, I have a 7, I have the square root symbol, and then I have a 3. So there's number 5. And we could say this as 7 times the square root of 3, or 7 radical 3. Okay, the next number that was assigned to you was number 9. And you can see when we get to number 9, well, we already have a 4 out in front. We call that the coefficient. And then we have a 20 as the radicand. So the first thing that I do is I'm going to make a factor tree of the radicand. 20 is 5 times 4, or I could have done 10 times 2. 5 is prime, so I cannot factor that any further. 4 you can factor into 2 and 2, and the 2's are prime. So I'm done with my factor tree, because you can see that I stop and I have nothing but prime numbers. Now when I rewrite this problem using my expanded factored form, I already have a 4, so I have to start with the 4. Then I'm going to put the radical symbol, then I'm going to write out my factors for 20, which was 5 times 2 times 2. Okay, don't forget to have that 4. That 4 is already out there as the front coefficient. Now I'm looking for identical pairs of numbers to simplify this, and I have identical 2's. So I get rid of them as the radicand, and I move it to the front. But I already have a 4 out there. Okay, now this does not mean 42. If you already have a number out there, or if you end up with multiple numbers in the front as the coefficients, multiply them together. So 4 times 2 gives me an 8. Then I have the square root, or the radical symbol, and you can see left over I have a 5. So this problem would simplify into 8, and then times the square root of 5. Moving on to number 13. Number 13, I have the square root of 3 times the square root of 6. And if you recall, the first thing that we do, if we're multiplying, we go ahead and multiply the numbers together. So the first thing you should do is you should multiply these two numbers together. 3 times 6 is 18. So this gives me the square root of 18. And then I simplify that number right there, the 18. So I'm going to make a factor tree out of 18. 6 times 3 is 18. 6 can be factored into 3 times 2. 3 cannot be factored, so I'm going to circle it, it's prime. 2 cannot be factored, circle it, it's prime. That 3 cannot be factored, so I circle it, it's prime. Okay, so then I rewrite my radical in its expanded factored form. So I get a radical symbol, and then I get a 3 times 3 times 2. 3 times 3 is 9, 9 times 2 is 18, so it should equal the radicand that I had there. Okay, now I'm looking for identical pairs of numbers, and you can see I have identical 3's. So those 3's get eliminated as the radicand, but they get moved to the outside as a 3. Why is that? Because 3 times 3 is 9. The square root of 9 becomes 3. So now I could write my simplified form. I have a 3. I have the square root symbol, and then I have a 2. There we go. 3 square root 2 is my solution to number 13 as its simplified form. Number 14, the next problem that was assigned to you, I have 4 and then the square root of 6, and I'm multiplying that by the square root of 27. Okay, so now what I do is when I multiply, remember we multiply first, then we do the factor tree and we simplify. So I have this 4 right here, and I would multiply it by the number in front of the square root of 27. So I would go 4 times whatever number is there. Well, there's no number there, so that means I have a 4. Then I multiply the inside, the radicand numbers. So I would multiply 6 times 27, and that would give me my square root. 6 times 27, let's see, that's a 2, that's 162. So when I multiply these two together, I end up with 4, and then I end up with the square root of 162. Whoops. No, 6 times 27. Sorry, I'm doing this on my calculator on the side. You can't see it. That's 162. I did it right. Okay, now I'm going to make a factor tree of my radicand, which is the 162. Okay, so I got to figure out what two numbers multiply to make 162. Okay, well, I got a couple choices here, and one way is, if you're not sure how to do it, you could start with 162. Whoops, let me pull this down, and you can see, maybe you can see, let me get it out of the glare here, to figure out what goes into 162. Sorry, I'm trying to move this around so you could see it. Oh, almost got it. We got it right there. Okay, and then you start dividing it. Let's divide it by 2. So, and it goes in 81 times. So we know that 2 times 81 is 162. So you could use your calculator to figure these out if you're not sure. I'm going to factor this into 2 and 81. You cannot factor 2 anymore, so I'm going to circle it. That tells me to stop. It's prime. I can factor 81 into 9 and 9. And I could factor this 9 into 3 and 3. So I'm going to stop because I can't factor 3's anymore. But then I'm going to factor the other 9 into 3 and 3 as well. 3 and 3 as well. So that means when I rewrite my 4, whoops, hold on. Lights just went out. There we go. We're back on again. So that means when I factor my 4, and my square root of 162, there we go. This is going to expand out into, I'm going to have a 4, and then I'm going to have my square root symbol, and inside of it, I'm going to have 3 times 3 times 3 times 3, 4 3's, yep, and times 2. Okay, now if you're not sure if you did it right, multiply these back out. 3 times 3 is 9. That's 9. 9 times 9 is 81. 81 times 2 is 162. Okay, so now I'm going to start looking for twins, identical pairs. You can see I have a identical pair of 3's. So that means they get eliminated from the radicand, the inside, they get moved to the outside. So I'm going to have a 3 out here. But I already have the 4, so I'm going to have to go 4 times 3. But then if you notice, I have another pair of 3's. So those get eliminated, and I have to put another 3 on the outside as well. So really, in front, I have the 4, which was already there, and I have a 3 and a 3, so I got to go 4 times 3 is 12. 12 times 3 is 36. So that means when I simplify this, I end up with a 36. Then I have the square root symbol, and the only thing left over is a 2. So number 14 would simplify into 36 times the square root of 2. Okay, jumping down to number 17, which was the next one you had to do. We had 7, whoops, there we go. We have 7 square root of 3. We're multiplying it by 2 square root of 15. So remember, when you multiply, you go outside number times outside number. So 7 times 2 gives me 14. Then you put the radical symbol, or the square root symbol, and then you go inside number times inside number. 3 times 15 is 45. So when you multiply this out, you get 14, and then the square root of 45. Okay, now we simplify. 45 is not a perfect square root, so I'm going to make a factor tree for 45. 9 times 5 is 45. Could have went 15 times 3. 9 can be factored down into 3 and 3. 3's are prime, so we're going to circle them because we stop. We can't factor them. Go up here to 5. 5 cannot be factored, so we're going to stop. So that means when I rewrite this problem, I have a 14 still in the front as the coefficient. Then I have the radical symbol, but instead of writing 45, I'm going to write the product of my factors, which is 5 times 3 times 3. And now I go about looking for twins, looking for identical pairs, right here, crossing them out, moving them to the front. But I already have a 14 there, so I'm going to move those pair of 3's to the front as 1, 3. So that means I have to multiply those values together. 14 times 3 is 42. So when I simplify this, I get a 42. Then I have the square root symbol, and inside I have a 5. So there we go, 42 radical 5 for number 17. Okay, the last 3 you had to do, or actually the last 2, was numbers 23 and 24. Now on number 23, you got to be really careful. So 23 says in parentheses, we say that the quantity, we have a 3 is square root of 7, but then we have to the second power. So here's what that means. That means you take 3 square root of 7, and since it's the whole part, the whole parentheses is to the second power, that means you have to multiply it by itself. So we get 3 square root of 7 and 3 square root of 7. We have to multiply those two together. That's what a second power means. Remember using this concept. Let's say I gave you 5 to the second power. Wait for it. There we go. Well, what does that mean? Well, that means you have to go 5 times 5. Okay? So when you have a 3 and a square root of 7 to the second power, that means you have to go to 3 to the square root of 7 times 3 square root of 7. Now I multiply these out. Remember, the rule is when you multiply these radicals, you go the outside number times the outside number. 3 times 3 is 9. Then you put the square root symbol, and then you go the inside number times the inside number. 7 times 7 is 49. Okay, so when I multiply them together, I get 9, and I get the square root of 49. Okay, now I'm going to look at this and go, all right, well, is that a perfect square root number? And if you notice, 49 is a perfect square root number. What is the square root of 49 equal to? Well, it's equal to 7. We don't have to do a factor tree for 49 because we know that that's equal to 7. So that means this part turns out to be 7. But I have this 9 here. So what do I do with the 9, which was already there, and what do I do with the square root of 49, which is 7? Well, we multiply them together. So number 23 becomes 63. So in this particular problem, even though I started a problem with the radical symbol, when I multiplied it out, I ended up with just 63. Okay, 24, we're going to do it the same way. So if you notice, we have a second power again. We have an exponent. Okay, so this means that I have to take 4 in the square root of 5, and I have to multiply it by itself. 4 square root of 5. That's what that second power tells me. Okay, now when I multiply, I go the outside number 4 times the outside number 4. That's 4 times 4, so I get a 16. Then I put the square root symbol, and then I go the inside number 5 times the inside number 5. The radicans times each other. That's 25. 16 square root of 25. Now the question is, do I have to make the factor tree of that, or do I know what the square root of 25 is? The answer should be, Mr. Trutna, I know what the square root of 25 is. It's 5. So this part right here just turns into simply 5. Not the square root of 5, just 5. Times the 16, which is already there. So 16 times 5 is 80. So there's your answer to number 24. Okay? All right, we'll go over more of these as we progress throughout the week.